All right, welcome to 4.1 and Math 31, which is where we start talking about, functions increasing and decreasing and getting in some of the useful aspects of the derivative. A couple things that I'd like to point out just right out of the gate with the notes, that when it talks about a graph rising over an interval, this is essentially talking about positive slope. We are certainly assuming that you're reading the graph left to right. So as x increases, y increases, that's positive slope. A graph is falling when it has negative slope. And that's the idea that, y is decreasing as x is increasing. That is super important, that increasing and decreasing are talking about the slope of the graph. So in order to talk about this graph, we're going to split it into sections where it starts, where the slope would be 0, and then where the graph ends. And I really do want to, explicitly say that at points B and C, the slope is equal to 0. And that's very important, that if the slope is 0, it's neither increasing nor decreasing. And we're going to exploit that fact as we work through the course, because that's actually going to allow us to find vertexes or vertices on graphs, which is a big advantage. Okay, so the above graph is increasing when it has positive slope. So that's from B to C. The graph is decreasing when it has negative slope, and that's in the interval A to B and C to D. So nothing too crazy happening there, right? Just talking about increasing is positive slope and decreasing is negative slope. Now, once we start to actually identify these as an interval, it's going to be really important that at B and C, it is neither increasing nor decreasing. So we'll have to use the open bracket, or, x or t or whatever it is greater than or less than those points. So it says, how can the derivative help us to determine if a function is increasing or decreasing? This kind of makes me chuckle. We're going to do this on the next page, but the function is increasing. And I really do want to write this, that f of x is increasing if f prime of x is greater than 0. So the derivative gives us information about the original graph, which means that f of x is decreasing if f prime of x is less than 0. And that's, I don't know if segue is the right word, because I pretty much wrote exactly what I'm writing. That's our first derivative, the test for increasing or decreasing functions. We're going to call that the first derivative test as we work forward. That's why I stumbled a little bit there. But it is basically just the idea that increasing of a function matches with the derivative being positive or greater than 0, and the function is decreasing when the derivative is less than 0. A lot of students initially will forget to take the derivative, and they'll just try to solve when f of x is greater than 0 or when f of x is less than 0. That would tell us if the function f of x is positive or negative, which can certainly have meaning in a ton of contexts. All right, I'm going to do one example and just kind of save the other two examples for part 2 because they're a little bit more lengthy. But for part 1, it wants us to find the intervals where it's increasing or decreasing. Just kind of one more time, I'm going to write that it is increasing when f prime of x is greater than 0 and decreasing when f prime of x is less than 0. Now, if we are going to talk about f prime of x, we need to know what f prime of x is. Now, this is a simple, sum and difference with the power rule. So f prime of x is going to be -5 plus 8 times x. So in order to solve, and I think it's important that the values that make f prime of x 0 are neither increasing nor decreasing. So there's one point, there's one x-intercept to that linear function where the function is neither. But if we can find the intervals where the function is decreasing, then anywhere else that the function exists has to be decreasing. Right? And it's one of those kind of binary conversations that the function is increasing or decreasing or has a horizontal tangent line, would have a slope of 0. So what we need to do is solve when is -5 plus 8x greater than 0. This will be my increasing interval. And I'm going to solve that, but then I do want to compare it against the solution for when it decreases, which is when -5 plus 8x would be less than 0. You're probably seeing why we did the review and preview, because there's going to be a lot of solving inequalities in chapter 4, which is certainly a double-edged sword, but typically students do like that kind of routine nature of solving inequalities. Well, if -5 plus 8x is greater than 0, I'm going to add 5 to both sides. I get that 8x is greater than 5. I divide by 8, that's a positive 8, so the direction of the inequality doesn't change, and I get that x is greater than 5/8. That is a nice terminating decimal though, so if you did want to say that x is greater than 0.625, that would be acceptable for sure. Writing that as interval notation, we'll summarize that at the end. Now, before I do anything, it's a pretty safe assumption that it's decreasing then when x is less than 0.625. And if we solve this decreasing branch of the solution, I get that 8x is less than 5. I divide by 8. I get that x is less than 5/8. So we see that those two intervals, other than 5/8 itself, when the derivative is 0, actually occupy the entire number line or the entire domain of the original function. So what I'm going to summarize is I'm going to say that f of x it's increasing when x is from 0.625 to infinity, or when x is 5/8 to infinity. Very important that both of those are round brackets, because at 5/8 it's 0, and infinity isn't an actual number, so we can't put equal to there. And it is decreasing when x is from negative infinity to 0.625. And again, just to be consistent, I'll put that fraction in as well. Oh, something went a little wrong with my negative infinity there. So from negative infinity to 0.625. Now, you don't have to write it, but I think it is important that it's neither at 5/8 or 0.625. But the function or the question just wanted to know when it's increasing or decreasing. It is increasing on these intervals and then decreasing on these intervals, minus my little spelling mistake there. And I'll just erase that for a little bit of kind of posterity. Oh, I was going to do the fraction there, and I forgot to. Sorry about that. That would be the 5/8. 0.625 is that fraction. Okay, that's part one. In part two, we'll look at kind of a little bit of nastier functions that are, quadratic or cubic or higher.